So it's time for the solutions to the end of year review number 2, which is all about functions. We spent a couple months on this stuff. The first thing we need to do is identify the traits of these functions, the graph versions. And there's a lot of different things you can identify, such as the domain and range. The domain is the x's, the range is the y's. You already know what x and y intercepts are. Intervals of positive is where the function is above the x-axis. Intervals of negative where it's below the x-axis, such as down here. And intervals of increasing is where the slope's positive, decreasing where the slope's negative. And behavior is what's happening as you go left forever and right forever. And then the asymptotes are any line that gets infinitely close to but doesn't cross. So, let's just take it one by one. Here's number 1. The domain on this guy, well, that's how far left and right it goes. Well, it goes left forever and right forever, so the domain is going to be from negative infinity to infinity. And you remember you do the open brackets anytime you have infinity. The range, on the other hand, is how far down and up it goes. Well, this line's going down forever and it's going up forever, so all real numbers is another way to describe from negative infinity to infinity. So the range is all real numbers, which you can write like that. The x and y intercepts, we have an x-intercept right there, which is at 4, 0. And the y-intercept is right there, which is just 1 above the origin, and that's at 0, 1. So those are our x and y-intercepts. The intervals where it's positive, well, it's positive up above this x-axis, and so that's up until it reaches our x-intercept, which is at 4. So everything to the left of that's positive, and everything to the right of that's negative. So it's positive from negative infinity until you reach 1. And it's negative from 1 onward to the right. And remember, when you're writing these intervals, always do it from left to right, left to right, left to right. So negative infinity is always before everything, so negative infinity goes first. Positive infinity is always second, because nothing's bigger than positive infinity, so you get that. The increasing interval would be where the slope's positive. Well, it's not positive at all, so there's no interval of increasing. But there is an interval of decreasing because it's decreasing everywhere, which is from negative infinity to infinity. The end behavior, I'm going to write that over here. Here, let me do the asymptote thing. Well, there's no asymptotes on this. There's no line it gets infinitely close to and doesn't cross. So that'd be none for this. The end behavior, when you're going left, and behavior you always write as x approaches negative infinity. Your function approaches what value? Well, this function keeps going up and up and up and up without bounds, so f of x goes to positive infinity. And for your right end behavior, you're going to write as x approaches positive infinity. And then your function, this one, keeps going down and down and down forever and ever and ever and ever. And so it's going to go to negative infinity. Here, let me fix the error. It goes to negative infinity. And so there's our first one. The next one's going to probably go a lot faster. The domain on this guy goes left and right forever. So the domain is going to be all real numbers. The range is not going to be all real numbers because it does go down forever. So it goes all the way down to negative infinity, but it doesn't go up forever. It goes up, up, and up, and it gets really, really close to 8. And hopefully you remember that exponentials never actually reach the number it gets really, really close to, but it approaches it, and it gets really, really close to 8. So that's why I have a circular bracket on 8, because it doesn't never reach it. The x-intercept on this guy is right here, which is at 2, 0. And the y-intercept's right here, which is at 0, 6. The intervals where it's positive, well, it's positive to the left of our x-intercept. It's positive over here, as in above the x-axis. It switches when you reach 2. So the interval where it's positive is from negative infinity to 2. And then it's negative after that. So from 2 on to infinity, it's going to be negative. This function is always going down, so again, it's not increasing anywhere, so we're going to put none for the increasing interval. It is decreasing everywhere, so we can put from negative infinity to infinity. Let's deal with the asymptote thing first. This one does get really, really close to a line, but not cross it, and that line is y equals 8, which is this horizontal line up here. The end behavior, again, starts as x approaches negative infinity. What does your function do? Well, as you go left and left and left forever, our function gets infinitely close to 8, and so it approaches 8 on the left side, that height of 8. As x approaches positive infinity, which is going right and right and right forever, I think I could draw an infinity symbol, the function keeps going down and down and down and down forever, and so this one's going to approach negative infinity as you go right forever. This next guy has a lot of different parts to it. So let's deal with the domain and range. It is going left forever and right forever, so domain is going to be all real numbers. The range is going to be the same thing. It does go down forever, goes up forever, so the range is also going to be all real numbers. The x and y intercepts, let's start with the x ones. There's one there, there, and there. And so those values are at negative 7, 0, 4, 0, oops, 0, and then 8, 0. And this one has a single y-intercept, which is right there, at 0, 3. So I can write all this down. The intervals where it's positive is anywhere it's above the x-axis, so in this chunk, and then everything to the right of that. And the intervals where it's negative are these two sections, this part here and this part here. So starting with the positive interval, that starts here at negative 7 and ends at 4. So from negative 7 to 4. And then picks up again at 8. So I'm going to put a little U symbol there. From 8 onward to infinity, that's going to be the positive interval. The negative intervals are going to be a little bit different. It's negative from 4 to 8. So I'm going to write 4 to 8. And I'm going to put a U there. And it's also negative here on the left side. Oh, that shouldn't be 4 to infinity. That's just 4 to 8. Sorry. And the other ones here on the left side goes from negative infinity to this x value of negative 7. So I put that down. And actually I should have switched these around just because usually you go from left to right in saying the intervals. Anyway, so there's that. So that's a positive negative question. Intervals where it's increasing or decreasing, well, there's a few of them. It's increasing right here as it's going up. It is decreasing over here and here. So it's got some weird parts where it's decreasing. And it's increasing again right here. So I'm going to do this right here. It is increasing on this section, which is from negative infinity until you reach this x value of negative 4. Negative. And it picks up again right here, which is an x value of 5, and continues to increase as it goes right forever and ever and ever. So I'm going to put positive infinity there. The decreasing interval, or actually it's just one interval, is from negative 4 to 4, so between these x values here. And it also continues on to 5 there. And so this one's weird. I'm going to write out two different ones. So from negative 4 to 4, and from 4 to 5. I'm doing 2 because there are two sections. And right here at 4, it's not... I don't know how to say it, if it is decreasing or not. But it is decreased from 4 to 5 right there. So those are those ones. The end behavior always going to start with as x approaches negative infinity. So as you go left forever and ever and ever, what does the function do? Well, this one keeps going down and down and down forever and ever and ever. So it's going to go to negative infinity. Whereas on the right side, as x approaches positive infinity, my function is going up and up and up and up and up without bound. So it goes all the way up to infinity. There's that, and then asymptotes. These ones are non-existent on this one because there's no line it gets infinitely close to but doesn't cross, and that's mostly because it's going left forever, right forever, up forever, and down forever. So there are no asymptotes on this, and that's going to be it for this video. Just these first functional property things.